Here's recording. You can start.
Okay, so thank you guys so much for coming along. Hopefully you can see from the title of my project what this is roughly going to be about. But I will jump right in because I'm aware that we've lost a wee bit of time, but that's fine. I'm just going to rearrange things so I can see the slides that you can, which is obviously important. Just to do a quick overview of what I'm going to be talking about today. I will introduce myself properly in just a second, as well as the kind of topic. I will quickly cover some of the details about kind of sign language and sign languages. So hopefully everyone has a rough idea of what we're talking about. So today makes a wee bit more sense. I'll go through some of the previous research that's been done in this area at the intersection of kind of either computer science or often just engineering more generally and sign language. Um,
Dan, sorry, apologies. The slides on your screen are, they've suddenly become a lot bigger. They were displaying very, very small for everyone on the
no
screen. They've
worries.
suddenly become bigger, so
Um,
great.
Hopefully that is fixed now. Um, is that still viewable? Yeah, now it's okay. Brilliant. Um, as I say, I'm not sure if this picked up on the recording. I did a whole trial run with the desktop version of Zoom. We got it working really, really slick. And then I'm happy to be on the browser version. But hopefully everyone can see it now. We'll go through some of the previous research, and then I'll start talking about my project and the kind of components that are needed for a system to recognize sign language, and kind of end by talking through what the goals that I'm seeking to achieve are in my project. So a quick introduction to me. My name is Dan. When I left school and went and did my undergrad for the first time, I did it in computer science, which is probably not too surprising given that I'm talking here today. But actually, shortly after moving up to Edinburgh, I took an evening class in BSL, in British Sign Language. I really fell in love with the language and I decided I wanted to retrain and become an interpreter. So I decided to go back to uni and do another undergrad in BSL interpreting, and that was actually here at Heriot-Watt. So that's how I arrived back here. But definitely enjoyed the studying and decided I wanted to keep going. And so finishing that degree in 2019, I actually started this MSc in data science. So I have come back to computer science, I've come back into the fold. And now when I was looking at my MSc project, what I was really wanting to do is find something that combines the two rather disparate fields of interest and find a project within computer science that looks at BSL. Um, and this is what this project kind of seeks to do. So just to kind of very quickly rattle through this, I realize that people won't necessarily have any familiarity with signed language or come across sign languages before. So I will quickly go through this. If it is too quick, please do say in the chat and I'll explain in more detail. But really, this is just so that we kind of have a rough grounding for the rest of the talk. So signed language, the various sign languages that are out there, obviously primarily used by deaf people, certainly not exclusively. There are plenty of people who aren't deaf that use them, but really it is the language of the deaf or the languages of the deaf. Signed language are visual gestural languages. So what I'm doing right now, I'm speaking English. I'm obviously using my mouth to generate sound. You're using your ears to perceive that sound, and that's how the modality of our language works. But a sign language is a different mode. It uses the hands, the face, the body to produce visual output, and the receiver would use their eyes to receive that output. So it is a different way of kind of communicating through space, but it is still language. Really, really important to highlight that sign languages are natural languages. They evolved over time in the same way that spoken languages do. There are a few examples out there of constructed systems that are based on kind of sign language or visual gestural systems, but that's not what we're talking about today. So if you've ever come across something like Makaton, that is something that someone sat down and invented and kind of came up with the ideas for. But when we talk about sign language, we're really talking about natural languages that evolved over time. Now, it's really important as well to highlight that they're not universal. There is not one sign language across the world. In this country, we use something called British Sign Language. That has similarities actually to Australian Sign Language, Auslan, for those of us joining from Australia today. But it is very different to, for example, American Sign Language, which has a very different kind of form and structure. It's worth saying that most of the grammar and structure across sign languages is fairly similar. I don't want to go as far as to say it's universal, because that's not necessarily true, but a lot of what I'm talking about today can apply to most sign languages, although obviously I will reference BSL because that's the language that I know and I can be sure about, but equally most of this would apply, maybe with some tweaks, to languages in other countries and other locations. So if you're familiar at all with kind of spoken language or English phonology, you'll know that our language is made up of phonemes, which are units of sound. So there are various sounds that we can put together, and that will form the words that we speak, and then those words confer meaning. So it's quite sort of linear. You tap together different sounds together, that will then form the word, and then that's kind of understood. Sign languages are based on what we call 5 parameters. So rather than just a single sound that we kind of link in units, there are 5 different parameters that can change at any given time. And that's what forms the basic of the phoneme, the unit of meaning. We do use the word phoneme, phonetics, even in sign language, just to kind of match up with the rest of the field of linguistics. I know that they're not sounds, but that's just a kind of convenience thing to make it clear that they are the same linguistic feature, even though it's a different modality. So the first feature is hand shape. It is literally the shape of the hand, and that forms the kind of the basis of the sign. There are plenty of hand shapes that actually have quite clear semantic meanings. So this is a very kind of hand shape. I'm aware that it's very light in here, so hopefully everyone can see what I'm doing. But this hand shape, you might not be surprised to learn, is a sign for good in the most basic form. But there are actually a group of signs that all use the same hand shape. So for example, smart across the forehead uses this good positive hand shape to indicate smart, which hopefully you agree is a positive word. You've got health, which again has this sort of positive hand shape. Beautiful on the face. So again, even though they're all different signs, they're all using the same hand shape. And in that category, those are all positive signs. The opposite sign you might think would be bad, but actually bad is this hand shape in BSL with the little finger extended. And you have a similar grouping of signs for that. So you have ill, which again is similar to health, but with the negative bad hand shape becomes ill. You have criticize as well, which uses this negative hand shape. So that there are plenty of abstract hand shapes as well. They're not all kind of semantically linked like that, but you can hopefully kind of understand that as the hand changes shape, the meaning can change as well. A kind of extension to that is what we call orientation. And what we normally mean by that is just the direction that the palm is facing. So not only can the shape of the hand matter, but also its kind of location in physical space and the direction that it's pointing. So another example for that, if I do this with my hands, with the palms facing upwards, that means now in BSL. But if I were to flip my hands so they're pointing down and I do this, that means here. So you can see that it's fundamentally the same sign, but by changing the orientation of my hand, I've changed the meaning that I'm generating. We then have location, which is the location either on the body or in the kind of space around the body that the sign is performed. And that will actually dictate even more meaning. Again, you have some nice semantic links here. So anything that's to do with kind of thoughts and thinking tends to be up at the head. So you have to know, to think, you have the term theory, all of that's taking place kind of at the head, which it makes sense because it's to do with the mind. A lot of emotions will take place on the body. I'm aware my microphone is here, so I don't want to bash it, but you've got love, you've got sad, you've got happy, all take place in this kind of area here. Again, where I'm just checking the chat. I don't think it's a question to me. Again, where the location has some sort of semantic meaning, but again, there are plenty of signs that have kind of abstract locations that don't confer that kind of semantic meaning. But that's another way you can kind of change the meaning of a sign. We then have movement, which is either a movement from one location to another, or it is to move in a kind of a static way. And again, it can change the meaning. So a good example for this is the sign true, which in BSL is that. It's the hand kind of slapping this one. However, if I do this sign, that's bread. So it's two almost identical signs. The only thing that's changed is the movement, but again, the meaning has changed. And there can be other variants of movements that can happen as well. The final category, which is definitely sort of last but very much not least, is non-manual features. So this is basically anything that isn't happening on the hands. And a mistake that people often make is assuming that BSL is all about the hands, or sign language is all about the hands. It isn't. A lot of the meaning is conveyed on the face, in the body, the way that kind of you hold yourself, that affects the meaning that you have. And a simple example, just to pick one, is that negation happens on the face. So going back to our sign for true, if I just sign it naturally, it means true. But if I add a shake of the head, that means not true. So you can see I've not done anything differently with my hands, but I've completely changed the definition of the sign by adding that kind of negation with my head. So as you're kind of hopefully starting to realize, there's a lot of things that go into just a single sign in sign language. And that's before we've even talked about some of the extra features that kind of link signs together and generally add to the kind of prosody of what you're saying or signing. So hopefully that wasn't too quick. People have a rough idea of what we're talking about. Feel free to kind of pop questions in the chat. I'll pause in a wee bit properly for some more questions, but if questions are coming in, just kind of let me know and I'll stop and try and explain. So now we're going to move on to talk about some of the previous research in this area. And I wanted to kind of first start with, this was really where some of my motivation for this project came from, because there are a lot of research projects that come out within the field of engineering or computer science that lack some of this grounding in linguistics or deaf issues. So the paper on the left, it was actually published this year. I think it was in January. It was published in a reputable journal, but you can kind of tell just from reading it that there was no involvement of either deaf people or people with kind of deaf expertise, knowledge of deaf linguistics and stuff. Just some of the language that's used, the use of deaf dumb, of mute, talking about deaf people communicating with ordinary people. You can just kind of tell that there hasn't been that involvement. And that kind of informs the fact that it's missing some of this usefulness for the community. A lot of the systems that we see coming out are what we call sign language gloves, which are basically kind of bulky gloves that the user is expected to wear, and that's how they can kind of communicate with hearing people. Now, you may be spotting the issue already from the slide we just did, of that if you just have the hand, you're missing out on a lot of information. And actually, you can see that on the right-hand side, which was a review of about 30 different projects, all of which were sign language gloves. And if you look at the column in the center, you can see that they are based on very, very limited subsets of signs. So some of them are just 26 letters. Some of them are just numbers. I think one was 4 words, 8 words. So they are very limited subsets. And just based on the hands, there's no additional information going into that. A lot of these papers kind of end by concluding that they achieve kind of 99% accuracy, which would obviously be wonderful. But if that's just based on, say, 4 classes of 4 different signs, then it's not actually contributing to a wider understanding of recognizing sign language, which is the project that I'm going to be talking about in a wee bit. And I'll explain what my goal is. And I was trying to kind of think of a good explanation as to why this is maybe not ideal. And I came up with this sort of thought. It's not a perfect analogy, but hopefully it helps to kind of think a bit about what the issues are. So I don't know if anyone's familiar with the kind of artificial larynx systems. There used to be a kind of box that people would hold directly against their throat. This one I found is a reasonably new innovation. This one actually won the was shortlisted for the James Dyson Award for Design. Certainly a lot more attractive than some of the machines that were maybe seen in the past. But still, if someone told you that they weren't going to try and understand your language, they weren't going to try and kind of learn your language, but if you wore this kind of quite bulky piece of technology, they would try and kind of recognize one or two of your words. I think you'd quite rightly be a little bit unhappy with that and not feel that was a particularly useful contribution. So there are definitely places for this kind of technology. And on the next slide, I'm going to show you where some of these things can come in. But I think what's important to bear in mind is that the reason a lot of deaf people don't perceive any value in things like sign language gloves is because of this idea of wearing some quite restrictive and bulky technology in order to understand a language that we can understand. I know BSL, I'm not deaf, I'm hearing, but I still learn the language. It's important to remember that it's not that deaf people can't communicate because they can't speak. They can't communicate because the person doesn't know sign language. And again, this sort of system, these sign language gloves aren't really a solution to that per se. But there has been plenty of research that has been a lot more well-founded, and that's definitely worth focusing on. We've got a paper here on the left, which is from 2000. I really like this paper. This was actually funded by the British Post Office. The idea was that there was going to be kind of video screens in post office counters that you'd be able to communicate with deaf people with this really kind of seamless system. It was a really ambitious project. I think that unfortunately in their kind of final paragraph almost, they kind of conclude that they possibly bit off a bit more than they can chew. What I also like about this is that I'm about to say that they were limited by the technology of the time. Even just the paper itself was limited at the sort of very old reproduction graphics that you've got there. But what you can maybe see, the guy on the left is strapped up to what looks almost like a lie detector. He's got equipment around his chest and his arms, on his hands, a whole rig on his face. And all of that was designed to capture sign language data. It was expensive, it was temperamental, but they were able to get some sign language data from it. And they were able to output it on actually what is quite an advanced model for the time. You can see that on the right. So they were trying really hard. They had a good linguistic grounding. They kind of knew what they were doing, but fundamentally they were just held back by the limitations of the time, both in terms of rendering computer graphics, in terms of the fact that there was no even attempt to perform this recognition using a camera. It was all just done with kind of bulky physical systems. And as I say, all they were really trying to do is do a few phrases that would be useful in a post office. So like next customer and please put your item on the scales, stuff like that. So even though they had quite limited goals, they still didn't really achieve what they wanted to just because of the limits of the technology. Moving on, it's not too far forward, but a few years later, we have this system in the middle. And this is another category of research that isn't necessarily about sign language recognition, but is about representing sign language. What you can see at the top there, those three symbols are part of a notation system, which is designed for writing down sign language. The notation systems are really, really useful for academics and researchers and recording of sign language where you're interested in knowing what the handshake was, what the location is, etc. But it's important to realize that actually they don't contain nearly enough information to fully recreate the sign. Having said that, if you look at those three pictures, and you'll see that the caption underneath it's the sign for 1, 2, and 3, and hopefully you can all work out which one's which. There is that information there, but it just the models didn't have that level of kind of detail. They weren't articulatable enough to really express sign language fully, and I think that a lot of the time comes from the problem with this notation system. I would liken it to sort of musical notation. If you've got someone who's a professional musician, they can look at musical notation and they can absolutely translate it back to a fully fledged kind of piece of music. But someone who doesn't have that expertise looking at that notation is not going to be able to understand all the kind of nuances and details that will be contained in those signs. But it is progress being made. We do now have a system that can kind of, I wouldn't go as far as to say that it can sign, but it can produce sort of things that are kind of getting somewhat closer to sign language. We see a few other examples of this. What tends to happen, though, is the conclusion at the end of a lot of papers is that the system just wasn't advanced enough, that when they evaluated it, it wasn't capable enough, either because the model wasn't good enough or because the system was too complex or something like that. But there has been some progress since that paper in 2006, particularly with the models, but similar conclusions throughout a lot of this research about the complexity. Finally, on the right-hand side, you have a paper that is actually from an ongoing project that looks really, really promising. They're going back to sign language recognition. So they're looking at taking video data and trying to identify the sign language within it. And you can see, I'm not sure how big it's appearing on your screen, but hopefully you can see that they've got quite a detailed sort of wire diagram of kind of the location of the head and the face and the hands of the signers. So that is really positive. It's really interesting research. One thing I would say about it is that it's still grounded in translation. So everything that they're focusing on is about going to or from, I believe it's English. I'm not sure if that's the spoken language they're using, but certainly it's going to and from a spoken language. So it's not kind of sign language in isolation in its own right. It's still being evaluated by whether or not you communicated correctly using this vector of another language. So this system actually isn't looking about representing sign language. There's nothing that's going to come out that looks like sign language, but what they're hoping is to directly translate videos of people signing back into a written form of a spoken language. So really useful kind of if it works, but there's no real way of understanding what's going on kind of under the hood and knowing what the kind of representation of the sign language data is, but still very promising. And as I say, that is a paper that's been published partway through a research project, so I'm sure there's a lot more to come from them. So I'm going to do a bit of a pivot here and stop talking about the previous research and start talking about my project. I'm definitely going to take a sip of drink because my throat is hurting, but it'd be a good chance to ask if anyone has any questions before I move on to talk about my project.
Dan, I just wondered, that was really fascinating. First of all, found that super interesting, like a really good insight into an area I know nothing about. So thanks for that. I just wondered what first, if you don't mind me asking, what first piqued your interest in sign language and what first motivated you to go to this this evening class a few years ago?
Yeah, so I don't have this kind of grand story of why I was interested. It was literally that I moved up to Edinburgh. I didn't know many people in the city, and I thought, oh, I'll get out the house and I'll do something, pick sign language, and that was literally it. So yeah, it wasn't anything kind of more grandiose than that. It was just that I thought I'd take an evening class. I thought it was just going to be something to fill my evenings for a few weeks. It turned out it took over my life a bit more thoroughly. But yeah, no, nothing more interesting than
Great.
that.
Yeah, thanks.
Any other questions before we move on? I'm also aware we are quite tight on time, so I will try and go through it. But if people are able to kind of stick around, I'm happy to kind of keep going. But I will try and rattle through and finish as close to 10 as I can. Not sure how well I'll do. But let me just quickly introduce my system in a whole before I talk about the parts. So what I'm aiming to do in my system is take in video data of people signing, and rather than outputting kind of a translation into English, effectively spit out the same thing again, but being performed by a 3D model. So the idea is coming up with a system that can recognize what signing is happening on the body of the signer, and re-represent that using a 3D model. And hopefully that will become a bit more clear as I go through the system. But as I say, it's not based on translation. It's based on understanding what we need to capture in these videos in order to effectively represent the language and understand what it is that we've captured. So these are the components that I've identified as being necessary. I am going to go through all of these in turn, so don't worry about taking all this in on the one slide. But just as a kind of very quick summary, the red system in the top left, that's about creating a 3D model. If you remember on the slide about the previous research, you can remember that there's been a reasonable range of qualities in terms of 3D models, but basically needing something that is really detailed, really articulatable to be able to represent that data. Moving down to the orange section, you then have to identify the pose of the person signing. So that's broadly speaking, where are the major parts of the body? So where is the head, the shoulders, the elbows and the wrists, identifying those within the video, and then not just realizing that that's a 2D point, but actually a 3D point, because if you imagine my hand moving sort of back and forth towards the camera, the position of my hand on the 2D frame hasn't changed, but obviously it's changed in 3D space. So that makes the task that little bit more complex as well. We then need to do the yellow area, which is the areas of interest. So for me, that is the face and the two hands, working out where they are so that we can then do some more recognition on them, which is then the green area, working out what the position of the face is and the hand shape, orientation and stuff like that. The blue boxes are about outputting that into a useful kind of abstract data form. So something that is independent from the input video. It's not based on the kind of the size of the input video frame, or even necessarily the kind of proportions or size of the signer, but something that's that little bit more abstract, so that it can either be exported to another system or represented on our model. And again, there's a part of that which is recombining the various models that we've got from the various stages into one coherent model. And then finally, you have this purple stage, which is representing that back to the user. Not necessarily in every application of this, but certainly to evaluate this project, it's going to be essential to be able to visualize what it is that we've created. So that first stage, that red stage, is needing that really highly detailed articulatable model. We need to be able to control it, move it around, position it in all the positions that we could find within sign language data. It was also really important to me that we didn't just have one fixed model. A lot of systems that I've seen within sign language and in similar systems have kind of one avatar that has been chosen. And it can be quite limiting for a lot of applications because you're limited to just this one appearance, which might be great for some situations, but if you find that actually you want someone that looks a little bit different, it's just not possible. So I also wanted something that was a bit more sort of swappable. I could talk in great detail about this, but I think it's much easier to show you. Having said that, I'm not sure how easy it's going to be on the browser version of Zoom, but hopefully, if I stop sharing and start sharing again, I can hopefully show you something. I think possibly it's only going to allow me to share my screen, not the application. So if I share that, can someone come on their microphone and tell me that they can hear it, because I can't then see the Zoom screen to know.
I can't hear anything as of yet.
You can't see anything, okay. Just to be clear, I'm not trying to share audio. I just want someone to confirm that they can see the software that I'm demonstrating.
It's just a black screen to me.
Okay. Right. In that case, I don't know that I'm going to be able to do these demos, which is a real shame, because it was working perfectly on the desktop version of Zoom. But I don't think I'm going to be able to do that, which is really, really annoying. I will vary my presentation again.
Yes.
Brilliant. And now hopefully you can see the model on the screen as well.
Yep.
Brilliant. Okay, we will get started again. Thank you for bearing with. So after those technical difficulties, we do have our system, which I can show you. So this is a software called MakeHuman, which is an open source piece of software that does basically exactly what I needed it to do. It's a really, really simple way of creating some really nice detailed 3D models. And what you can see here is that I have this, this really quite detailed 3D model. I'm going to show you in a minute how it's very articulatable. But what's really nice about this is not only did this only take me about 5 minutes to make, but it's really, really flexible. So you can change the ethnicity of the person here. You can change their proportions, move this in and out. You can change their height. You can change their weight, their kind of musculature, or kind of how fat or thin they are. You can change their age. You can go right down to baby. I realize it looks a little bit skewed because you can also change some of the geometries to match things like age a bit better. You can also change the gender. Again, you change other features as well. But what's really nice is these are all really continuous sliders. So if you wanted to, you could create quite an androgynous, quite a neutral model, which would be perfect for kind of giving out certain information where you don't actually want to bias it by the appearance of the person signing. You want the information to take the forefront. But equally, you could match the signer to the model to the signer if you wanted to, either by gender, ethnicity, age. So all of that can be really, really important. And as well, you can choose things like different hair and eyes and clothes and teeth and stuff. I won't go into a huge amount of detail, but just to sort of demonstrate how flexible the system is really, really useful. If I now jump over to Blender, which is a popular software for kind of editing video, you can see that our friend has jumped over with us. MakeHuman integrates into Blender. And again, you've got this 3D model. You can ignore the fact he's not wearing any shoes because I'm just going to be looking at the kind of top half of the body. But you do still have all the detail in the whole system. If I then switch over to the layout menu, we lose a bit of the detail, but it is the same model. And what I can actually do is turn on give me 2 seconds. If I then turn on this model, you can see that what we actually have is this skeleton that has been created by MakeHuman and rigged in Blender. And what this actually allows us to do is position the model and move them around. So what you can see is I'm actually dragging, and I'm not actually dragging the wrist here, I'm dragging this control, which actually infers the position of all of the bones that link to the wrist, as well as the clothing and the arms and all of that. So I can actually move this around in free form. And you can see that the model is adjusting to naturally position the rest of the body in the kind of relation to where I'm placing the wrist. So that's just a quick demonstration of how you can have this really effective articulatable model with just a wee bit of effort coming from these two pieces of software. So moving on, let me just switch slides. So moving on, the next stage of the process is pose estimation, which I talked about earlier. I'm going to try and rattle through, so I will get through this hopefully as soon as I can. But pose estimation is basically about working out where in the frame the position of the person is. So the input is obviously 2D frames of video. We're not working with any kind of 3D data. There have been projects that have looked at using things like the Microsoft Kinect or other more advanced systems. But fundamentally, a goal for me in this system was just using a camera that kind of anyone would be expected to have and not using something more complex that wouldn't be kind of recreatable. So what you need to do is you need to work out where on the 2D frame the joints are. And what we actually produce is, rather than an exact location, we produce a heat map. So where we sort of think that the location is. And then we can take that and we can actually work out where in 3D space the joints are, using kind of facts about the kind of relative length of bones and joints and stuff like that. So what you can hopefully see towards the right-hand side is you get this kind of 2D key points. And then that can be translated into a 3D pose. And that is actually used to then inform where we put the skeleton that I just showed you in Blender. Again, though, I can show you this in a live demo. So again, I'm hoping that you can see this on your screen. This is the code that I have run to do the first stage of it. So I haven't done the 3D stuff yet, but I have done the 2D stuff. So this is actually an existing model from another paper. I'm just going to get this loaded up, and then I will share the screen with you. So hopefully, if I go back to Python, if I go back to that, hopefully you can see this kind of very slow moving video, and I'll explain what's happening. So this is actually a video from an open access sign language corpus. And what we're doing here is quite naively just labeling the points. So rather than using it as a heat map, it's just a simple bit of code that says if the confidence is over a certain threshold, we put the label on. So that's why the labels are kind of popping in and out of existence. That you can see that it's doing fairly well. I will quit that and I will move to one I prepared earlier. So this is the same video, but it's just pre-rendered because as you saw, it was happening quite slowly. So hopefully people can see that. And what you can see is that the points are following the locations of the joints. So they're not always appearing because the confidence does sometimes drop slightly. But you can see that we're tracking the shoulders, the wrists, the elbow, and the head and the neck. So we have a rough idea of where this person's joints are. And we can then use that in the rest of the application. So I'm just going to pause that and come back to my presentation. Please do give me a shout if there are any questions. I don't see any questions, so I'm going to quickly move on. So the next stage of this, as I said, was extracting the areas of interest. So we've now got past the point of the stuff that I've done in kind of pre-experiments. So this is all now slightly more theoretical, but hopefully should all be doable nonetheless. So once we've identified the kind of rough position of where everything is, we then need to extract where the hands and the face are. So as you can see here, we've got our signer on the right, and we'd want to extract the kind of pixels around the hands and the pixels around the face to be able to do further processing on that. It may well be necessary or helpful to do some sort of pre-processing. So for example, if you look at her left hand, which is kind of pointed to the side, it might be that we'd want to kind of orientate all of the hands to a fixed orientation to make it easier to process. And we can do that because we know the location of the forearm. So we could adjust in that sense, but it may not be necessary. We'll have to see kind of how we get on with the next steps. So the next steps are actually doing the recognition on the facial features and the handshake recognition. In terms of facial recognition, this is something that is pretty well established. I had to put this little picture in here. I hope you saw this news story from a few weeks ago. If you didn't, it was a lawyer in a US court case who was on a Zoom meeting and had the filter that you can see on the right stuck on and was appearing as a cat. So the reason I put it here is to say that you hopefully are all quite familiar with systems that can do facial feature recognition. So it's quite easy to work out where whether the mouth is open, often where the eye gaze is. The question in this project is not going to be if that's possible, but just is there enough detail in the system to use it for sign language data, because we don't just need to kind of put a cat image on top of the person. We need to do something a little bit more nuanced. But it is a very well established domain, and it should be fairly easy to integrate into my system. The slightly harder system to integrate will be the handshake recognition. You've got an image here from the BSL Sign Bank, which is part of the BSL Corpus project. And these are just some of the handshapes that have been recognized as part of BSL. You can see that there's a sort of fair whack of them, and there's quite subtle differences between some of the different handshapes. So trying to identify enough detail to be able to recapture these handshapes will be fairly difficult. Having said that, it is a limited domain of possibilities. I'm just seeing the comment in the chat. Yes, but yeah, the handshapes are a limited range of possibilities. So it may be, if it's not possible to get that kind of really high replication of every kind of joint in the hand, it may be possible to go back to a kind of classification problem and try and classify the hand shapes into one of these forms. What I would say is this is one section of my project that is probably the least important for a kind of successful delivery. It's obviously vital for something that can fully capture sign language, but actually if we had everything else in the project other than this, there would still be kind of use in it for researchers in terms of being able to automatically process sign language, to automatically do some tagging, even though it would be missing the data about handshapes and stuff. It would still be very useful to have the hand shapes kind of identified where they are, have the face kind of cropped in. So stuff like that could still be useful. Although obviously my goal is to make sure that there is success in kind of all areas. We'll have to see what happens over the summer. The next bit of the project is actually very simple. It's just about combining the models into one. The slightly complex bit is making sure that they are in a kind of abstract space, so they're not dependent on the kind of pixels from the input video. So the idea for this is that if we take a common kind of anchor point, so it might be, say, the bottom of the neck, and then measure where the joints are relative to that using a measurement from the body. So maybe the shoulder width, for example, using that to work out where the joints are, and using that to create a kind of abstract model of where the person is in space. There are a few systems out there already for representing facial expressions, representing body positions. They may well be usable. It will have to be a case of experimenting and finding out if they are, or defining my own space, but hopefully at least some of the existing systems will be usable for this purpose. And then finally, it's about making sure that we can actually render the output. So the first thing that would need to be done is actually pose the model, which is about positioning the model that I showed you earlier using the inferred model from the signer, making sure that that's done and then rendered in a way that humans can see. We don't have any really well tagged data for this with exact positions of kind of where every joint and every location is to test this data automatically. And it's just not realistic for me to create that within the scope of this project. So this project is going to be evaluated by human evaluation, whether the output videos are linguistically expressive, whether they've captured the information in the input video. So it's really important that it is re-rendered out to be able to do that evaluation. So finally, I'm going to wrap up with talking about what my goals are for the project. A really big goal for me is just quantifying how complex this task is. I think that there are a lot of misconceptions about sign language and thinking that it is simpler than it is. Hopefully, I've convinced you at least somewhat today that it is a very complex task, but being able to kind of properly articulate that and record how complex this is, I think is going to be really useful for demonstrating why we need such complex systems to tackle this problem. I also really wanted to decouple sign language recognition from translation. As I mentioned earlier, a lot of these projects rely on some sort of translation as part of their system. And not only does this make the whole thing a lot more complicated because translation is a very complex task, but it also can sometimes hide some of the complexity of the actual sign language. And of course, we're in a lab that is about explainable AI and making sure that we know what we're talking about. So I think that having something that's that little bit more low level is going to make it a lot more possible to actually demonstrate that this is doing what we think it's doing, and it's not kind of going via English, it's using sign language in its own right. So that was a big goal for me. But ultimately, what the goal of the project is to convert video input into something that is both machine readable, but also human readable, and having that model that could then be output to either researchers, to academics who are researching sign language, to the direct rendering that I've mentioned, There are actually some direct applications of just if I got this project done in terms of being able to send sign language data in a much smaller file size. Obviously, if you've got an HD video of someone signing for any length of time, the file becomes quite large. But if you had a much simpler model that you could send and re-render, that would obviously be a lot smaller. There's a really valuable, there's a lot of cat puns in the chat. I'm not sure if that's being recorded, but some great cat puns coming through. But there are some really great applications for this in terms of anonymizing deaf people. So at the moment, it's very hard for a deaf person to do something anonymously, for example, make an anonymous complaint, particularly if they were, for example, complaining about, say, a sign language agency, interpreting agency. There's that real risk that the person that's going to be translating their complaint to kind of anonymize it could be the interpreter themselves or someone that knows the interpreter, stuff like that. So being able to have someone sign to a camera and translate that to a neutral 3D model, which could then be submitted as the anonymous video, would be really, really valuable. And the other really big obvious application of this is having kind of editable sign language. So as someone who did a 4-year degree submitting BSL videos, I can tell you it is a huge pain to try and submit something and you make the tiniest mistake, but there is no way of going back and fixing that because it's midway through a video. So actually having something that you could kind of chop and change and merge together would be incredibly valuable. Even if it was for things like websites where information changes, being able to change one little detail in a video would be hugely valuable, as opposed to having to kind of recreate the whole video just for one minor change. So I realized I rattled through that very, very quickly. Hopefully we're not too much over time, but I'm very happy to take any questions that anyone has at this time, if that's helpful.
Trying to get my... Thanks a lot, Dan. Sorry.
You're working. That was... Can I? Anyone